DNS provides a fabulous service in resolving names to IP addresses, but like many good things, it can be abused. For example, let's say we have an attacker out on the internet, and that attacker either has a botnet or he has purchased the services of a botnet in some type of cloud service. And unfortunately, being able to just purchase or rent a botnet is a real thing. And if the attacker who's controlling that botnet wanted to take down our DNS server, what they could potentially do is go ahead and have their thousands or tens of thousands of devices all send in lots and lots of DNS requests into our DNS server. And we could randomize the domains. It could be like blah 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 blah.com or .com or .com. The domains don't have to exist, because what the DNS server is going to do, if it doesn't have the domain cache as far as the IP address, it's going to go ahead and use a forwarder, or it's going to walk the DNS tree in looking for that. And that's because these requests coming in are all recursive requests where the clients are asking, just like Bob over here, here's what I need, please let me know when you find it. Either give me the result or tell me you can't do it. So the DNS server, either from its cache or by walking the tree, is going to go ahead and determine to the best of its ability that information and then feed it back to Bob. So now going back to our botnet that's doing this, the botnet, when they send those DNS requests, they are not using their real IP addresses. So they're spoofing source IP addresses when possible. There's hundreds of thousands of requests coming in. There's all kind of wacky domains that are not in the cache. And so this DNS server can be overloaded and have a denial of service attack. And with the botnet involved, it's referred to as a distributed denial of service attack. You can learn more about those in our Certified Ethical Hacking course here at CBT Nuggets. And the bad news is for us as the managers of this DNS server is that a server can fairly easily be compromised and brought down unless we take precautions against allowing those recursive lookups to be sent to us from the public internet. Because by default, our DNS server is allowing the recursive DNS request to come in, and it'll go out and solve it for us, or do its best to solve them for us. So one solution to helping with this problem is use Nancy Reagan's approach, which is just say no. We could go ahead and turn off the feature of recursive lookups, and then when the clients make a request, wherever they come from, the server, if it has it in the cache, can respond to them, but it won't bother going ahead and doing an iterative lookup to other DNS servers, including forwarders, to try to resolve that for them outside of itself. However, if we turn off the feature, that is a problem for Bob. So what we can do is we can go ahead and control the recursion on the DNS server using DNS server policies. So with the DNS server policy, we could say we want to allow DNS recursion to happen if you're within a certain scope. So for example, this DNS server, it very likely has one interface that's going to the public, to the internet, and a different interface that's going to the private network. So in our policy, we could say we want to permit, for example, traffic coming in on this interface to this IP address, allow the recursive queries there, but not allow the recursive queries on the interface that is facing the public internet or the untrusted networks. So in our lab environment, that's what I like to walk you through. And then after we do it together in the video, I'd like you to do the hands-on lab and practice it on your own. So in our lab, I've logged on to our Windows 10 client computer. And here on the Windows client, let's go ahead and open up the integrated scripting environment by using the icon here in the taskbar. And I've already got some commands that we're going to use here, so it's not as much of a typing exercise, but rather a learning exercise. And then you can reinforce these commands as you do the hands-on in the hands-on labs. So before you and I make changes, let's do a baseline test. So I've opened up a remote tab to DC-nug, Control-Shift-R will get you there quickly, or you can use the file menu. And I'm just going to go ahead and clear the DNS server cache on DC-nug by highlighting that row and pressing F8. We'll click on yes to confirm. Then we'll go back to our client tab and we'll clear the DNS client cache as well by highlighting row 3 and pressing F8. And in your case, as you do the lab, you would type out those commands, and that will help reinforce those commands for you. And then we'll highlight row number 3 and do an NS lookup for server2-nug.nuglab.com. With that highlighted, we'll press F8. That resolves great. And then we'll do a resolution for google.com, specifically a host www looking for an A record with NS lookup. And we'll go ahead and press F8 to execute that. That all looks fantastic. Name resolution is working like a champ. And just to confirm, let's also launch the DNS manager. I'm going to click on the window icon in the bottom left-hand corner, type in DNS. The DNS desktop app is highlighted. We'll press enter to launch that. And here's our two servers. So we'll expand DC NUG, and let's also expand server 2. And if we look at the properties of DC NUG, so let's click on DC NUG, and with this selected, we'll right click, and from the drop down, let's select properties. Under the properties of DC NUG, you'll notice that on the interfaces tab, by default, is listening on all IP addresses. So one way of protecting our server is just to identify the interfaces that we want the DNS service to function on and deselect any of the others. That would be a step in the right direction. So in this case, we only have one interface, and we're allowing DNS requests on our IPv6 address as well as our IPv4 address. But if we had multiple interfaces and multiple IP addresses, we could go ahead and hit the radio button for only the following IP address, and then deselect the interface IP addresses where we do not want it to process requests. So I'm going to leave the default as all IP addresses here, and we can also modify the behavior with DNS server policies as well. Also in the properties of this DNS server, let's click on the Advanced tab. And here on the Advanced tab, we can see that by default, recursion is allowed. So there's no check by default in the checkbox that says Disable Recursion. So as part of our configuration, we can disable the default policy for recursion and then create a specific scope and permit recursion when requests come from within that scope. So I'm going to click on Cancel, not make any changes here, and let's go back to our PowerShell. Here in PowerShell, we'll click on the tab for the DC NUG server. I'll click on the squeegee to clear up the output a little bit. And the first thing we can do right here in PowerShell, and we also could have done it in the GUI, is we can disable on the entire server recursion. And the PowerShell command to do that is set DNS server recursion scope -name, and then there's a period right there, which refers to the server that we're actually configuring this on, which is DC NUG, and then a dash enable recursion, and then $false. So if we execute that command by highlighting it and pressing F8, then if we go back to the DNS manager, and let's right click on dc-nug.nuggetlab.com, and from the drop down do a refresh to make sure we're looking at the latest and greatest information. Then if we right click on the DC NUG server, and from the drop down select properties, and go back to the Advanced tab, you'll notice that now DNS recursion has been disabled. So I'm going to close the properties box right here. And let's go back to our client just to verify that this DNS server is no longer willing to go out and ask additional DNS servers for information on our behalf. So here on the DNS server, let's go ahead and clear the DNS server cache to make sure nothing's sitting in the cache. So with row 3 highlighted, for the clear command, we'll press F8 to execute that. Then we'll click on yes to confirm. And then let's go to our client tab, which is tab number 1 right here, PowerShell 1. So let me go ahead and use the squeegee to clear the output. And let's also clear our local DNS cache on this client by highlighting row 2 and pressing F8 to clear the DNS client cache. And then we'll do an NS lookup for server 2. Now, because server 2 is in a local zone on the DC-NUG server, it should be able to respond to that directly from its local zone files. So with row 3 highlighted for an NS lookup for server 2, we'll go ahead and press F8 to launch that. That's great. So there's our DNS server that we used, and there's the response to the question, what is the IP address for server 2? However, if we ask our DNS server now to go out and look for us for that information, our DNS server is not going to do it. So let's go and search for an A record for www.google.com, which, because we just flushed the cache a few moments ago, it shouldn't be present in the cache, and this server is not going to go out on our behalf looking for it. So that includes not using the root hints and not using any forwarders that are configured. So with row 4 highlighted, we'll press F8 to execute that. So here we have query refused. It was not doing recursive lookup requests and asking any other DNS servers on our behalf regarding resolving www.google.com. So that's the first step to protecting our DNS server, is turning off the recursive query function. However, that doesn't make it very useful for people who want to use this DNS server, for example, our internal employees. So what we could do is we could go ahead and set up a DNS server policy. And to do that, let's go back to our DC-NUG tab. And in row 5, I have the syntax for creating a scope. And the syntax is add DNS server recursion scope -name, and then I put this string in quotes, I'm calling it our people, and then space -enable recursion $true, meaning if the scope of requests match our people, then go ahead and allow the recursive request, meaning the server will go out and make the iterative request on behalf of the client who made that request. Now the next problem is that the server has no clue exactly what the scope our people represents. So what we can do is we can create a recursion policy that not only says allow recursion for that scope. But as we create the policy, it also specifies what that scope represents. So the syntax is add-DNS server query resolution policy -name, and then you give it a name in quotes, our recursion policy or your recursion policy, whatever you want to name it, and then -action space allow, and then -apply on recursion -recursion scope, and then here's where we define what the heck our people represents. So we said to allow recursion on our people, and now here in the policy we're defining what our people means. And to see the rest of it, I need to scroll to the right a little bit. So let's scroll to the right a little bit. And here it defines our people as -server interface IP, and then in quotes, the string EQ, 192.168.1.100, close quote. Effectively meaning if DNS requests come in on this IP address on the DNS server, we're going to allow the recursive queries to come in and we'll process them. Meaning that the server, when it gets a request, can go out and make iterative requests on behalf of the client who made the recursive request. So let's go ahead and scroll back to the left and let's execute these. So with row 5 highlighted, we'll hit F8, which identifies the label of the scope of our people and also specifies that we should enable recursion if requests come in from that scope. And then for line 6, we'll highlight that and press F8. That's the one we just went through. And if we scroll to the right a little bit so you can see everything, here we can piece the whole thing together. So it's add-DNS server query resolution policy, and then it picks up right here with name, and that's the entire tail end of it right there. So if you want to pause the screen right here while you're doing the labs, so you can replicate this, that way you can see the entire command right here. So what we'll do is we'll go ahead and highlight row number 6 and press F8. And because I tried to execute it twice, it said, It said that recursion policy, our recursion policy, already exists. So if you want to add it again, you're going to have to remove it first. So if we wanted to remove it, and I'm going to do it just for grins, we can go ahead and use a remove-DNS server query resolution policy with this name. So I'll go ahead and execute that by highlighting it and pressing F8. I'll click on yes to confirm. Then we go ahead and clear the screen with the squeegee. And let me go ahead and add it back in by doing row 6 one more time and pressing F8. I just want to make sure I got them in nice and clean. And as far as the remove statement, I'm going to get rid of that as well. You'll only need that if you're going to remove it and put it back in and remove it and put it back in. Another option would be you could just reload the lab and start from scratch and have a nice fresh slate as opposed to having to remove it manually. Okay, so now for our test. Let's go ahead and clear the DNS server cache. I'll highlight row 3. We'll press F8. We'll click on yes to continue, and then we'll go over to our local client, which is the first tab. We'll do a squeegee, and that clears off the output. Let's clear our DNS cache. With the clear-DNS client cache, we'll press F8 to execute that. And then we'll do our NS lookup for www.google.com, looking for a type A record by highlighting row number 4 and pressing F8. And now that works. Even though it's globally, the default recursion policy is turned off, for our scope called our people, which is any requests coming in on that specified IP address, the recursion requests are still allowed. And also, because our local DNS server just cached that information on that request, if we did an F8 and launch that command again, we still get the answer, but we also have some more information regarding it was a non-authoritative answer, and that's because it came from the cache on our DNS server. And now, my friend, it is your turn. Now, on one of those strings, it was so darn long that I thought, I want to make it a little bit easier regarding those huge strings to be able to study and practice with them. So if on the lab computer, you right-click on Notepad, there is, in the recent history, a document called recursion commands. And if you expand that full screen, you'll still have to scroll a little bit to the right to see it all. But there's the 3 commands that we issued in this nugget to turn off recursion globally, to establish that we want to allow recursion for the scope of our people, and then our policy that allows the recursion for our scope and also defines that the scope includes any requests coming in on that specific IP address. And with that, my friend, it is your turn to practice this in the hands-on lab environment and have some fun. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.